Okay, product to sum formula. This is about representing a product of two things, say sine A times cosine B, you have product of two trig functions, as a sum of two trig functions. And the way you do it is by first writing down all the sine sum formula, sine difference formula, all these. You should write these down first. And actually, it's better if you can just recall these by heart, and then you can picture everything in your memory. Then the formulas that you write over here is just automatic. But let me show you how that works. All you have to do is take this identity and add them. Then you get sine A plus B plus sine A minus B, right, on the left side. What happens on the right side?
Cosine A sine B cancels.
They cancel.
These two cancel, yes. And this one doubles, right? So you have 2 times sine A sine B, cosine B. And then you can divide by 2 both sides. And suddenly you have a way to represent sine times cosine. It's 1/2 of sine A plus B plus sine A minus B. So you get this as your result. It's 1/2 sine A plus B minus sine A minus B. Okay, then you can think about other cases. You can think about the case when cosine is multiplied to sine, but that's same as sine times cosine. You can just switch places, so that's not anything new. And the remaining 2 other possibilities are when you have cosine times cosine and sine times sine. Okay. So let's think about cosine times cosine. Now for that, you just take this, the cosines, sum of cosine angle formula, just add them, just like before, and divide by 2. What happens? You get this plus this, divide by 2, and that's going to be just this one, right? Dividing by 2 cancels the 2 in front of cosine A, cosine B. This one cancels. So you can easily see what should be here, right? So that's same as 1/2, what? Cosine A plus B plus cosine A minus B. Okay, that leaves us with the last possibility, sine A times sine B. What should we do? First, where do you see sine A times sine B? Here, right here, right? Yeah. But if you add them, it cancels, so instead of adding, what should we do?
Subtract.
Subtract. Good idea. So we're going to subtract instead, and we'll still divide by 2.
Other side will cancel.
Then this one will cancel, but it will be -2 of sine A sine B, right? So you instead of dividing by 2, you have to divide by -2, or you have to multiply by -1/2. So that's a slight change from the other ones. See, if you subtract, you end up with -2, so you have to divide by -2. And it'll be cosine A plus B minus cosine A minus B. So you have these product to sum formulas, and I suggest that instead of memorizing this, just make sure that you can recall these very well, and just do the math in your head. Just think about what sine A plus B is. That's sine A times cosine B, right? And then plus cosine A sine B. So when you have, why did I put minus? Sorry, that's a mistake. Sorry about that. So if you add them, then the second part will cancel out, right? And you have sine A times cosine B doubled, so that's what's going to survive. Just do the proof in your head, then it will just naturally make sense. Think about the cosine A plus B. think about cosine A minus B. This one is cosine A times cosine B. And the other part is sine A sine B, but if you add them, the sine A sine B will cancel out. The cosine A cosine B will double, and you put 1/2 in front. That's why it's going to be same as cosine A cosine B. Just do the math in your head. If you subtract instead, you're going to get -2 sine A sine B. You divide by divide by -2, and you get sine A sine B. So that's a really nice way to do it. Okay. Now let me show you an example of using that for integration. Okay, compute integration of sine mx sine nx dx from -pi to pi for m not equal to n, okay, and mn are integers. Okay, let's try this. Okay. So for this one, we apply the product to some formula. And this is this third case when you have sine times sine, right? And that's same as -1/2 of cosine A plus B minus cosine A minus B. So this integration would be integration from -pi to pi of cosine of this plus that, which is m plus n times x, plus cosine of this angle minus that angle, so that's m minus n times x. But then all this has to be multiplied by -1/2. Right? We don't have room, but that's -1/2, okay? And you integrate.
Why is it plus cosine?
Oh, it should be minus, thank you. Thank you. All right. Now, we know that integral of cosine is sine, but because of the chain rule, the reciprocal of this number should be in front. Okay? So let's pull the -1/2 outside, and we're going to integrate cosine, which gives you sine m plus n x with 1 over m plus n, then minus 1 over m minus n sine m minus n x. You have to plug in pi and -pi. Okay, there's something that you have to know about the sine function. If you look at the graph of the sine function, it's 0 at 0, it's 0 at pi, at 2 pi it's 0, it's 0 at 3 pi, 4 pi. So what you see is that if there's an integer times pi plugged into sine, you always get 0. If n is an integer, and evaluating sine at integer times pi, you get 0. So what that means is that if you plug in pi here, you get some integer, because m and n are integers, the sum is an integer. So sine of integer times pi, that's going to be 0. Same thing over here. Same thing if you plug in -pi, because negative times an integer is still an integer, right? It still gives you 0. So either way, when you plug in pi or -pi, it's going to give you 0, so this will be 0. Now, question. Why is it important that you need m not equal to n?
You have to divide by 0.
Because then this will become 0, the division by 0. So another question that naturally arises is, what should you do when m and n are equal? Then you get cosine 0, right? What's cosine 0?
1.
1. So for that case, so note, if m and n are equal, then this side, I know it's going to be giving me 0, but this won't be giving me 0 anymore because that's just integrating 1. So it's negative 1/2 times negative 1. So you're going to get negative pi to pi of negative 1/2 times negative 1 dx. And that's just 1/2 x. Well, this is an even function because constants are even, so I can just write it as twice of 0 to pi of 1/2 dx, which cancels, so you just have integration of 1, which is x, and you plug in pi and 0, and you just get pi. So that's what happens if m and n are equal. But if they're different, you get 0. Now notice that it will be really hard to get this result without the product to sum formula, right?